Hello everyone, welcome back to Dragonfly Engineering. So this week we're going to continue on the new project of the Cartesian robot that is going to be mounted on the dual shot molding machine behind us, and its purpose in life is to pull molded parts out of the molding machine and drop them onto a conveyor next to it. So this week April really digs into building out the control cabinet. This is placing the electronics in the cabinet, as well as the Raspberry Pi computer that she's going to use to program the system. And I am starting the process of pulling all the old pneumatics hardware off of this robot system. And I've pretty early on decided not to use these huge pneumatic air cylinders that originally ran this machine because compressed air is expensive in this shop. So we are going to use servo motors and belt drive. So hope you enjoy, and a lot of this may be set to music or time-lapse. And let's dig into tearing off all the old gear on this frame and keeping what is salvageable. And thanks for watching Dragonfly Engineering. Please like and subscribe too if you'd like to see more of this series and other manufacturing content. Made in the USA.
Alright folks, I got in there and did a little sanding after the hole's been cut. Now we're going to get this one here. I've got some holes. So the idea would be put that here and put that there. Alright folks, we're going to start wiring our board. Basically, all these are connected laterally. Or these are connected laterally because this is the power lines. These are connected vertically because our chip will be sitting here and here and here.
All right, so we're on the back side of the robot. So this would be the side facing away from the molding platen. And yeah, so the molds would be on this side. And a lot of the old pneumatics controls are here. A lot of these are just wires and sensors. They go to this control box. And this tray right here actually is an E-track tray. And what that is basically a tray that allows this track, which in this case is like a squashed, like electrical conduit that's flexible. Well, that allows the wires to follow the carriage as it's traveling back and forth. And the Z-axis E-track actually isn't an E-track. It's just like it's kind of interesting. It's a vacuum hose, basically, that they use to transport the wires, which in one of the other clips, you probably saw how I just cut all of this off with the die grinder to free up the old Z-axis from the rest of the machine. So there is still useful hardware like hose clamps that I can reuse in the manufacturing line here. You can see right here how continual wear on something has caused this spring conduit or spiral metal conduit to actually rub through. And this, you know, who knows how many hundreds of thousands of cycles of this track following the carriage has caused this rub through, but this may be enough for me to decide not to reuse this otherwise pretty robust electrical track, just because this is worn out. So whatever caused it, which is probably just this back edge up here, is going to continue to cause it. So yeah, it's good to know. This is nice design input from a 20-year-old in-field machine. I guess all of this has to come off. No. Yeah, this whole box up here is loose as well. And yeah. Okay, but I am going to focus on removing all of this stuff down here. Again, since this is a pneumatic system, it has very little use. But some things may still be useful. Like this looks like oh, there's a dampener up here. Like this may be like a travel limit dampener that could still be useful, and it's got air hoses to it. So yeah, we'll find out what all this does. Or it's all junk because it's been used forever, and there was a reason they threw this in the alley. So let's see. Yeah, these are compression fittings. Yeah. Well, I'm going to focus down here. Oh, you can see a mirror of me in the oven that I got. Okay, screwdriver. These are induction sensors, which we are going to reuse because they don't really wear out and they're on this track. So I'm going to disconnect these now. Yeah, even the little connector snapped. And yeah, we'll pull these off. This inductor mounting track may still be useful. It looks like it's relatively intact. And this basically just provides a sensing limit for the carriage to tell the computer to stop. So when this piece of metal here gets over this inductive coil, then this sensor will send 24 volts to April's system to tell her system that, okay, the carriage just homed to the home position. And it's using these metal pieces as basically just steel or ferrous metal to trigger this inductor. So I'm sure our system will have a different starting point, so I will go ahead and pull these off and keep them. And everything seems to be half frozen up. So these screws don't want to unscrew either. This is the inductive sensor. They even have a little target at the top. So you can still see that. And then there's just a 3-wire connection at the bottom. And this is 24 volts power, ground, and then the signal out. Now this one actually has wing nuts. So this is an adjustable. They use this one to basically set the beginning and end of travel manually. But we're going to use the Raspberry Pi and the motor encoders to do all of that, so you don't have to crawl all over the molding machine every time you set up a new mold in your machine. Again, all of this hardware is very useful for these kind of systems. Yeah, someone just stuck this strain relief or this spring. As it broke off, they just shoved it back under this this zip tie here. I guess I need wire cutters too. I think this is metric hardware. It's got some mounting screw holes. Unfortunately, the bolts have broken off. Huh, this looks like a hollow metal manifold of some sort. There's a gauge on here. Like I was saying, this seems to be a hollow aluminum manifold because there's an air line coming into it, a busted off air line, some other brackets and things. And then some sort of sensor here, which may be like a safety sensor that there's air pressure. I have to show this one to April. She may want to use this as a safety tool moving forward. But yeah, that's it. It's made in Japan. And I think it's a pressure is there or pressure isn't there sensor. PS7. Copal Electronics in Japan. Interesting. It's got the similar connector as the other inductors have. But it also is, whoop. Uh-oh, I may have just killed this one. I wonder if I can get in here and fix this. Anyway, oh, this is vacuum. Oh, okay, so this is a vacuum manifold. Interesting. Well, I think this gauge is dead now. I don't think it's supposed to do that. It was probably dead before I got to it. I don't think a gauge is supposed to be on the side. like that. I think it's supposed to be centered like that, but this one was like that. So I'll just throw this one away. But yeah, so this was the vacuum system, it seems. So I guess this sensor, since that gauge said inches of mercury and measured vacuum, this could be a vacuum detector where it tells the world there's a vacuum on this airport right here. I'm not going to lose sleep over dropping that gauge, or that analog gauge, because I'm pretty sure it was completely destroyed anyway. All right. Yeah, I don't know what busted off here. That's, yeah, that looks like a metric thread to me. Yeah, metric threads are usually a finer pitch in general. Not always, but in general. So, but it's all rusted, so it's hard to say. But still useful hardware. So this isn't a hollow casting, by the way. It was cast. It looks like. Yeah, you can see the ejector mark for the casting ejecting out of some mold. And they drilled and tapped pipe fittings here and here, and then they drilled this direction, and then put another pipe fitting on the end, which has broken off. So this wasn't a hex plug, but that's another busted off feature. Probably, yeah, I don't know what it did, but this is probably just scrap aluminum at this point for us. All right, so moving on, we'll take this valve manifold off, and again, this is all old pneumatics. And you know, they use compression fittings, but maybe that was in vogue at the time. But I much prefer the push to connect stuff. But it seems like none of that is on here. But compression fittings are still usable if you've got plastic tubing. And you can get the compression ferrule off of the plastic tubing itself. If there's some types of compression fittings where a ferrule pinches down onto the plastic tubing, and if that happens, sometimes it's not recoverable. So let's see. Oh, okay. This one just jams into like a kind of a barb situation, and then this nut compresses down on it. Oh, I think there's. Let's see here. A lot of times with compression fittings, it's not worth trying to recover it. Like this one, I think it has a third piece that went on here that pinches down and compresses onto the tube itself. In fact, I can spin it. I can push it back. But again, I don't think it's worth trying to keep this stuff, because the push to connect things, the more modern fittings, are reusable and a lot easier to deal with than these old compression fittings. Yeah, it has like a ferrule that's on here that once it compresses down, you can't really get it off without cutting it off. Like this side, I worked it a little more, and I can spin it on the tube, but it's pretty much jammed in there, and you can see how the tube is mushroomed out around it, so you can't really get it off. So again, you kind of need fresh ferrules, I believe. So if we cut this tube in half, we can get the nuts off. And yeah, maybe these ferrules will come off. But it quickly becomes an exercise in futility. Oh, there it goes. So, well, Okay, there's the ferrule. So you need to keep this ferrule along with the kit of your brass collar. And then this ferrule is actually what clamps down on the tube itself. So who knows, maybe we'll keep some of this. And then we can keep it by putting it all back together. See? Yeah, I can't even, oh wait. It goes this way. All right, so that's a kit ready to reuse, a compression fitting.
All right, folks. I've got my 5-volt power supply. I've got the little legs attached. I've made marks on this aluminum holder of where the leg holes should be drilled. So I'm going to work on drilling that. Got my bit loaded. Going to just make sure that I get it right. All right, folks, we're going to get our 5-volt power supply screwed into 1, 2, 3, 4 holes here. So originally I'm going to have this protect the PCB. So the PCB is going to be, the board is going to be inside this aluminum housing. We're going to be sticking these guys here. But I need to drill holes, so I'm going to template this a bit.
Now these are pneumatic valves that are integrated, and you can always, sometimes you can tell that it's a pneumatic valve because they've got the air exhaust muffler on them, which is this thing right here. All right, we got an M6 here. I had actually a English hex key in my metric set. There we go. Been on here a long time. I guess my cheater bar is not exactly mil spec. Oh, there's some rust in there. So this is like an integrated valve, like a hydraulic system, not discrete like single-use valves. But since I need to cut all of these tubes off, oh wow, look at all that. It's pretty complicated back there. It's got adjustment needle valves and everything. I have a strong feeling that this thing is just worn out though. So that's the thing. It's hard to say if this is still useful or not. Not to mention that the contacts are busted. So yeah, like this is broken on the side. Maybe I should cut this and put it on the bench and do like a more in-depth dissection of this valve, this pneumatic valve, and see if it's useful in the future, or even for this instrument. It's just that, you know, I'd have to fix this situation. And there's a couple of pins. I wonder if, oh, you know what? I guess maybe the coil is in here. I don't know if there's you'd have to power this up and then get a piece of metal and see if it sticks to a coil inside of there. But I'll bet maybe there is a electric coil in here, and all we're doing is actually actuating on two little tiny pinholes. You can see these little pinholes? Maybe these are what actually pushes through. Yeah, if you look on this side, right here, looks to be what is a metal pin. So I'd have to put 24 volts on this thing and see what happens. So I don't know if it's worth anything. Okay, so we can see what's going on in this box. It seems like it's welded. It's got tabs that are welded to the main weldment. I can see how it's bent up here. So let me go around to the other side and we will unscrew some of that and see what there is to see. There's some crud in these screw heads. Let's see if I can get some pliers. All right, fortunately these screw heads have a little bit of a body on them, so maybe we can get them off with the old vice grip. Yep. Oh, look at that. This is the wiring central. Okay. So this is basically just a big wire breakout. And it goes to probably a Euromap style connector that plugs into the molding machine itself. So this multi-pin connector, which we don't have the other side of, is probably what you know, told the molding machine, okay, done grabbing the part is this pin, go ahead and mold next part is that pin, and but we have no idea what standard this is. I guess I could look at old labels, but again, it doesn't really matter. But this is a really nice wiring, like manifold. I may get this for April, and it's on a DIN rail mount too, so she may want this for her work. In fact, maybe I'll go get her. All right, so April, I was uncovering things and saw interesting wiring, so maybe you probably go around and see a little better. Let me see if I can unscrew one of these. It all goes to this connector, which is probably obsolete. You know, it's like an old mill spec connector, which probably went to an ancient molding machine. It's not Euro map, but like probably strictly analog.
They all have numbers. Do you have any idea of the sensor that it goes to?
Oh, I have no idea. But the fact that we've got a lot of terminated wire and these DIN rail mountable terminal blocks is interesting. Oh, and they're individualized too. Look at that.
Yeah.
Oh, cool. Well, we're probably gonna have to
Oh, I think.
take this mount.
Yeah,
this
you
whole,
gotta take that off, I think.
Yeah.
And then.
I wonder how I get the DIN rail off. Or do these snap in? You think?
Well, that's just the edge.
The end cap?
Yeah, I think the thing is after you
Or they all slide off.
after you take this off, this grouping mechanism, then you can start sliding them that way. Off the DIN rail.
Do you want to incorporate these? Do these look useful, or are you far enough along in your layout wiring design that these are? We'll use these for the next instrument.
the terminal block itself is interesting.
Oh, okay.
The individual wiring, I think you either have traceability between one.
Or just having wire that's already crimped. You know, like.
The other thing that could also be going on, I don't really know, but you remember how we had talked about the low side and high side of the 24-volt signal was going to be inside the E-track, so that the E-track could be minimalized.
Oh yeah, have a bus.
Now I'm just going by color, but this is being all red. Could be service to individual entities, sensors or whatever. I don't know.
There's a whole lot of grounds and a whole lot of blues and a whole lot of reds, and then signal in the middle.
This could be some of that signal bifurcation or power bifurcation.
Yeah, we'd have to.
That we had talked about.
We'd have to like follow one and
trace it out. Yeah. Because I mean, you know, I'm kind of guessing on color, but you know, unless you know 213 goes to whatever.
Oh, I have no idea.
Yeah.
I mean, no one would know.
Yeah.
Unless we had the original instruction or manual for this thing.
Well.
All right.
I mean, the other thing is we've planned for six mag sensors and 6 Keyence sensors, and this is well more than that.
Yeah, but my thought is, well, true, but you know, if we just used one of these rows, just the not having to crimp and label hundreds of wires, that may save you a lot of time by just reusing this kind of stuff. For instance, this is one of your inductor plugs that's already terminated.
Actually, now that's actually kind of helpful because we can recycle that.
Yeah.
And that would have three,
they're
three
all
wires.
going in here. So this is kind of like your sensor array.
This is all your. Yeah, I think you can save. I would.
In fact, we could probably reverse engineer.
I would save all. Oh, that one got a little chew on it somewhere.
Oh, that's just from the nylon thing.
Well, anyway, I think that you can save all of this kind of stuff.
Mm-hmm.
And then
this being these are the connectors for the inductors that we are pulling off.
Right.
That we're going to reuse. So this.
Correct.
These plugs work together.
But
And,
I'd save.
these don't go bad just sitting
No.
throughout time.
Tiny little spring cleaning, but you
Yeah,
know.
yeah.
But no, they've got the terminals here can be recycled and reused. I think.
Let me unscrew one of these and we'll see what is on the ends of these wires. Because these were like, I think this is all, oh, interesting. Okay.
Oh, the den rail come apart?
Well,
I can't see it.
it's bits and pieces of some old standard.
Well, it does look like it's electrically connected between the blue and the white.
Yeah, I don't know. So there's no rhyme or reason to their color coding, it seems. Because a red one is also connected to a blue wire that's labeled 101. But just having a ton of pre-labeled, pre-terminated wires, I think, is very helpful.
So does this block fully come off with the tool, or?
Well,
Because it's
if
awkward
we can get the, it's all on this den, so we'd have to. The den rail screw is here.
Sorry, different question. Does this box come off or not?
Oh yeah, with these two bolts.
Yeah.
Yeah.
Mainly because then we can kind of put it.
Oh, put it on a bench.
Or take it over to the electronics lab or whatever. Might be like less awkward.
Agreed. So let's see if we can get this off of here.
Yeah.
This is kind of real-time discovery.
And some of this cord minding is helpful too.
Yeah. This may have been made in Japan. But a lot of the...
Well, the sensor is made in, like, what was this, little mag sensor?
Yeah, and there's, yeah.
Is that a solenoid?
Kurua, and this is a vacuum sensor, which is also made in Japan.
Oh, okay.
So, it's kind of...
Oh, yeah.
I'm pretty sure this is Japanese.
What is
Oh, and they misspelled...
Kopal, Japan.
One of the labels is misspelled too.
Oh, whoops.
Like an R was put in instead of something else.
Oh, that's okay.
I mean, that's just more evidence that this is probably Japanese made. Okay.
Oh, okay. So it does. Okay.
And I guess I don't want to cut the wires short because having long wires is useful.
Let me look on the other side.
So useful?
Yeah.
Okay.
I'll take.
Take the whole lot.
Yeah.
All right. Well, I'll start digging this apart, and I'll bring this basically spinal cord of wire over to you with this. I don't know. Maybe this box would be a subcomponent in your stack, or well, it's up to you. But it seems like it'll save a lot of time.
Put a bow on it.
Yes, I will. Valentine's Day. It's a little too far away.
Okay.
The middle connector is definitely. It'd be nice if we had the other end of this connector, but we don't. So, all right, I will keep at it. Well, we got a little bit of progress going on this machine. I was able to get rid of some of the old dead pneumatics off of the frame and actually harvest a lot of wiring harness for April so she can get her new control box going, which we showed interleaved progress on her side and my side. I think she did a little more progress this week. But also testing the travel, it seems to still function generally well. Down here, the Z axis and the rest of the Y axis still needs a little bit of work. But looking at this bearing block here, which is the main driver, it has some stiction, but I think if I clean it up, then this thing may still be good as well. There's just a little bit of rock in it, so the bearings may be a little worn out, but this style of bearing is not over defined, so there's a fully defined bearing on the left side with a ground in rail, and then on the right side is almost like a following roller, so just rollers rest on this bearing, which is just a rectangle basically. I think they follow on this axis and this axis. So with the rollers over here, the fact that this bearing block feels a little loose may not be as big of a problem. Again, in the next episode, I'll probably get into cleaning up all of these bearings and assessing exactly what we have to work with as far as the mechanics. This robot doesn't need to be ultra precise as long as it can get down to the plastic part in the molding machine and suction cup it or grip something, then it can be within, probably 0.5 millimeter or even 1 millimeter and be fully functional for the rest of its life. So it's not a precision mill bearing that we're trying to create here. All right, well, thank you for watching Dragonfly Engineering. See you guys next week.